So I decided to take this Leader LPS 162A power supply that I've had sitting on my bench for quite a while to repair and take a look at it over the last week or so. Fortunately, I have an identical one over here that still works, and I pulled the lid off of that. But some of the steps I looked around online and I could not find a manual for this particular power supply. But in searching, I found a couple of other manuals. I ended up finding a LPS 152A manual and a LPS 160A manual on eBay. And the 160A pictures on eBay had images of the 162A board, and this is a 162A. So spent a little while looking through this, figured out what was going on with it, and ended up looking at the power stage on the schematic for the 162A, checked voltage rails coming in, checked a lot of the control stuff, but ended up finding out that I believe R39 was smoking hot, and started looking, and I'm trying to figure out why there's so much current flowing, and it ended up that D1, which is just this reverse protection diode, was actually shorted. So I temporarily cut that diode. It's just a 1N4001 general purpose diode, and the short went away, but we still had no output. And I continued looking, and I started looking into all the voltage loop control, the current loop control, and comparing the two supplies, and stuff was looking similar but not, and I was seeing that I had negative voltage across the output, which I thought was really strange. And it dawned on me that in looking out here, I was having no control voltage measured, and I said, hey, why don't I have any feedback? And one of the things that's broken on here is this positive terminal. And so I had this alligator clip hooked to the positive, and I stuck a meter on it, and I took a resistance reading across the output, expecting to see R6, and when I did that over here, I had like 620 ohms. When I did it over here, I had like 5K and a capacitor charging. So upon further investigation, the 680 ohm resistor back here is still there, it's still good, but if we look, the one thing that's in series with the positive output on the way to the feedback is the amp meter. And I'm like, huh. So I took a resistance reading across the amp meter, and sure enough, the amp meter is open. So we have no circuit output, so I took the positive alligator clip that I already had, tied it to the other side of the amp meter, and boom, it came to life. So we really have two things going on here. We had a bad diode shorted across the output, and we had a shorted or an open amp meter, and I think it was probably something to do with playing with these as a kid. Who knows what I was doing to them, but they're pretty rugged, and a couple of simple parts will be able to get them up and running. These meters are custom to this, and if you can look, it's off, and it's got 10 volts on it. It does move, but there's no adjustment in the adjustments. So I'm going to be looking to either find some replacement analog meters, which would be great, or some digital ones just to have it on board. Need a new banana plug and something to short across here. And looking at this one, which is still working, I don't know if you can tell that the caps are most definitely bulging and have some gas pressure in them, whereas these don't. These are rigid on top. So I'm going to end up ordering probably four new caps just to have it. So fun little project. Spent a couple hours on it. Probably going to have, I don't know, $50 in repairing the supply, including the manual. And my goal here is to post that manual. I scanned it, so I'm going to post it up on EEV blog forum just so people have it. So hope this helps someone. Have a great day. So I've got the final part in for the power supply. As you can see, we're doing about 1.4 amps, fully controllable. Take the jumper off, 14 volts, all the way up to peak voltage, and down to 0. Yep. So the last part I was waiting on was a small isolated DC to DC converter that takes in, I'm going to call it 0 to 80 volts. The reason I had to do that was because the only power source that I could find in here that was isolated from 12 volts is the actual main supply output. And so I've tacked on the rectified AC into this converter. Basically, we're going to put a piece of heat shrink over it, and that runs the meter. Works perfectly fine. Doesn't care if I give it 40 or I give it 0. It can handle it, and that's literally just running this meter. Current's hooked up, everything is all set, and I'm going to call this power supply complete. There is one little thing, every once in a while it reads 10 amps, and it actually is doing 10 amps of output, and when that happens, I think we've got some oxidized contacts in this header, J2, and I pull it off and I reseat it and it works, so I'd probably hit it with some contact cleaner here. But we're going to call the LPS 162A power supply complete. Thanks for watching.